So this problem is called Children Watching TV, and it goes like this. In a certain town, a survey found the number of hours grade school children watch TV per week is normally distributed with a mean of 20 hours and a standard deviation of 2 hours. If a child is chosen at random, what's the chance they watch less than 16 hours per week, more than 22 hours per week, or between 18 and 20 hours per week? Okay. So we're going to tackle each part of this problem separately. And the way we're going to do it is to draw pictures of the areas that we want to calculate and then look those areas up in a standard normal table. Now we know that this distribution is a normal distribution with a mean of 20 hours and a standard deviation of 2 hours. So let's write down the mean is 20 and the standard deviation is 2. All right. Now let's draw a picture of this. So we'll see what that looks like. There's the normal curve, and if the mean is 20, then that goes right in the middle here, and the standard deviation would give sort of the width of this curve right here. Okay, now if we're going to look up the area that's less than 16 hours per week, let's draw 16 in right here. And then if it's less than 16 hours per week, then the area I want is down here to the left of that. All right, so that gives us the chance that if we choose a child at random, that's the chance that they watch less than 16 hours per week. So this area represents the chance they watch less than 16 hours per week. Okay, so areas underneath a normal curve represent the amount of data involved. All right, so how do we solve this kind of problem? We need to change this thing right here, the x distribution, into z-scores and use the standard normal curve. Okay, so let's draw a picture of that. We're going to change this into z-scores over here, label this as z. Then in the middle here, we're going to have 0. And this 20 over here is going to be the thing that corresponds to that 0. Okay, so over here in the z curve, if we look at 16, it's going to be over here somewhere, and I don't know what that z-score is for that, but we should be able to figure it out. And then the area that I want is this area right here. All right, now how do we figure out this z-score right here? The way to do that is to use the standard start to use the z-score formula, and that looks like data minus mean divided by the standard deviation. All right, so let's put in what we have here for this formula. Data we have from up here, it's 16, the mean is 20, and then the standard deviation is this 2 over here. So put all of that in. Then 16 minus 20 is minus 4, 2 on the bottom, so minus 2 altogether. So this z-score up here is minus 2. All right, so this value right here is minus 2, and I want the area to the left of minus 2 underneath the standard normal curve. So this is the standard normal, and this is our original normal distribution. All right, to look that area up, I can use the standard normal table, and that goes like this. Remember, the table gives us the area up to a z value from the left-hand side, so I just need to use the z value I have there. So I put in minus 2 here for the z value, and then go to the table and look for minus 2 and minus 2.0. That area is going to be 0.0228. 0.0228. All right, so the area right here represents, this is a decimal right now, but I could write this as a percent, and to the nearest percent, it's about 2%, right? it would be 2.28%. So to the nearest percent, it's about 2%. That means this area is 2%, and that means this area over here is 2% as well. So the chance they watch less than 16 hours per week is about 2%. All right, so now you get the idea for how these problems work. We can go pretty quickly with these other two parts. Let me draw it over again. Remember, we have 20 here, and then we're going over to, and our standard deviation is 2, and then we're going over to z-values over here, and they wind up, 20 winds up in the middle there. This time we're looking for something that's more than 22 hours, so we're looking for an area that's over here. All right, and so we'll see what z-value that is over here, and then we'll have an area to the right of that we need to find. All right, so the z-score this time is still 22 minus 20, so it's data minus mean, divided by the standard deviation, which is 2. So that's 2 on the top, 2 on the bottom, and that's 1. So this z-value over here is equal to 1. And that tells me that the area, well, if it was the area to the left of the z-value, I could look it up directly in the table. But I can't because I've got the area to the right. I want the area to the right of that z-value. But the area underneath the entire standard normal curve is 1. So I can get that by just taking 1 minus the table lookup of my z-value, which is 1. So I put this z-value into here. And if I subtract those, that should give me the area to the right of z equal 1. So in the table, if I look up z equal 1, it's 0.8413. So if I subtract those two things, I get 1 minus 0.8413, about 0.1587. Or if I round that off to the nearest percent, it's about 16%. So this is 16%. And this is also 16%. Okay, so that's my answer for this part. And now I got one more part to do. What if I'm going to do the area between 18 and 20? So that's going to look like this. Here's 20 here. And this is x. Now this time 18 is right here. So I want to find the area between those two, so I want to find this area. Alright, so if I change things over to z-scores here, so it'll be z here, 0 in the middle. And I need to figure out what, well, not over there. I need to figure out where this value is right here that corresponds to 18. And then I'm going to have this area right here. Okay. So let's figure out what the z-score for 18 is. The z-score for that is 18 minus 20 divided by 2. That's our standard deviation, remember? Okay. And then that's minus 2 up here, 2 down here, so that's minus 1. Now, if I'm going to find the area between two z-values, the trick for doing that is I need to find the area up to the upper limit by using the table, and then subtract off the area up to the lower limit by using the table. So that gives me the area between two z-values. So I'm going to do a table lookup of 0 minus a table lookup of minus 1. All right, so the table lookup of 0, if I look up 0, of course, that's 50% of the area. So I could have guessed that. I didn't need the table to look that up. But the table lookup for minus 1 is 0.1587. So when I subtract those two, 0.5 minus 0.1587, I get 0.3413. Or if I round that off to the nearest percent, I get 34%. So this area is about 34%. And that means my original area over here was 34% as well.